Let's just jump right in today because we're going on a really fascinating journey. We're tracking the path of a builder, starting with the actual hands-on creation of a physical smart cabin, and taking that all the way up to understanding the massive, invisible data sets that literally run our modern world. Now, you might think hardware and software are just completely different universes, right? But today, we're gonna see exactly how they link up. Whether you're just starting out or you've been coding for years, you'll get to see firsthand how the tiny logic inside a simple device scales all the way up to global data systems. Let's get into it.
Okay, here's our roadmap for the explainer today. Number 1, the smart cabin logic. 2, sensors and interactions. 3, Python list indexing. 4, Python list traversal. And finally, number 5, powering big data. It's all part of one big, unified builder's journey.
Let's kick things off with section 1, the smart cabin logic, establishing the core conditions. So everything we build in the physical hardware space relies entirely on establishing clear conditions. Without a basic logic structure, a smart home is really, well, it's just a plastic box with wires, right? It actually needs to know how to behave based on where its owner is. So the cabin's functionality splits right down the middle into two totally different states. On the left, we've got at-home mode. This one is active, it's energetic. You're home, so you want the cabin to respond to you. We're talking a doorbell ringing for visitors, dynamic light effects, and remote doors opening with just a quick button press. But now, look over at the right side, away mode. The vibe totally changes here. It's measured, it's secure, defensive. When you're out, the cabin basically turns into a guardian, recording voice messages from visitors and locking things down with password locks. Two completely different modes demanding completely different behaviors, all from the exact same hardware. Now, the big question. How does the system actually know which mode it's in? Well, this perfectly illustrates the power of code. If you press the star key, boom, the mode switches to at home. If you press the hash key, it switches to away. And that's it. Literally just 2 lines of code acting as the ultimate switchboard for the whole house. It really goes to show you don't need 1,000 lines of complicated code to make a massive physical change. You just need clear, simple logic. Moving on to section 2, sensors and interactions, bringing the cabin to life. Okay, so once our core logic is set up, we need the cabin to actually interact with the physical world. Let's look at how we trigger outputs, specifically the lighting. You press key 2, and the cabin lights up with this awesome rainbow effect. Hit key 3, and you get a flowing light pattern. Key 1, that gives you a nice, calm atmosphere light. Key 4 kicks off a rhythmic breathing light effect. And naturally, key 0 shuts the lights off completely. It's immediate cause and effect. You press a button, the code grabs that input, and your physical environment instantly transforms. How cool is that? But hey, what if the input comes from nature instead of a human? Enter the rain sensor. We have this function, getRain, that's constantly checking the weather outside. The huge takeaway here is how the physical world gets translated into raw data. When it's dry, the sensor throws out data near 0. But the very second it gets wet, that number spikes to around 700. The code grabs that exact number and prints it right to the middle of our display. Real-world, physical changes turning instantly into back-end numbers. Which brings us to section 3, Python list indexing, the back-end data engine. So we're doing a bit of a pivot here. We've seen the tangible smart home hardware, but how in the world do we organize all the massive amounts of data those sensors are constantly collecting? Well, we shift gears into pure back-end logic using Python lists. That's what makes this kind of complex data organization possible. Let's define list indexing. It's basically a method to extract a specific element from a list by targeting its exact numerical position. The format is super simple. You just type the name of the list, followed by brackets containing the index number. Try thinking of a list like a giant row of gym lockers. Indexing is simply knowing exactly which locker number holds the exact piece of data you want to grab. Another way to look at it? Think of an index exactly like a dart hitting the bullseye on a dartboard. Out of all the possible spots it could land, the index lets your code strike one exact, specific target inside a much larger list. There's no guessing, there's no searching around, it's just instant, targeted retrieval. So let's see how this actually works in real code. Say we have a list named nums that contains the numbers 1, 2, and 3. We then tell Python to print nums bracket 2, and the output is 3. Wait, why? Well, it's because of this fun little quirk in computer science. Computers start counting at 0. So the first spot is actually index 0, the second spot is index 1, and the third spot is index 2. So by asking for index 2, our dart hits the exact target, pulling out the number 3. It's simple, it's super efficient, and it is absolutely crucial for managing data. All right, section 4, Python list traversal. Moving through the data. Okay, so indexing is fantastic if you just want to find one single item. But what if, and this happens a lot, you need to go through every single item in a list of, say, 1,000 sensor readings? That is exactly where the for-i in range code block comes into play. This is our traversal tool. Think of it like an automated assembly line worker. It lets us use the index to systematically step through a list, position by position, right from the beginning to the very end. And honestly, the best part, it doesn't just let us read the elements, it lets us actually modify them on the fly as we pass by. And pulling off a successful traversal, it honestly feels like a superpower. In our source material, we use traversal to access a list and programmatically change every single element inside it to the word parrot. Whether you're changing a bunch of text to parrot, or maybe converting 1,000 temperature readings from Celsius to Fahrenheit, traversal lets you do the whole shebang all at once with just a couple lines of code. Finally, section 5, powering big data, scaling up to change the world. So, how exactly do the micro skills of list traversal we just talked about build the macro world of global data science? Well, here's the big aha moment. Traversing a tiny 3-item list using a for loop, it uses the exact same fundamental logic as traversing millions of data points on a global server. The foundational coding skills that make a tiny smart cabin function are the exact same tools that tech giants are using right now to analyze the globe. The scale changes, obviously, but the logic remains exactly the same.
Okay, so what actually is big data? Simply put, it's massive data sets that are just way too large for traditional processing. But seriously, don't let the term intimidate you. Just think about your everyday actions. Big data is your daily web browsing history. It's your phone usage metrics. It's the GPS tracks of millions of cars on the highway and the delivery records of every single takeout meal ordered in a city. You are generating big data every single day without even thinking about it.
And why does traversing these massive lists matter to us? Because the applications are literally world-changing. By traversing millions of health records, doctors can actually predict disease outbreaks before they even spread. By processing endless lists of vehicle GPS data, urban planners can reduce citywide traffic congestion. And by analyzing purchase data, companies can give you those highly personalized recommendations you see online. Traversing these massive real-world lists allows us to solve massive real-world problems. It's truly the engine of modern innovation.
And that brings us to the end of today's explainer. We've gone all the way from pressing a button to turn on a rainbow light in a single smart cabin to understanding how traversing arrays powers global big data solutions. The tools are exactly the same. It's really only the scale of your ambition that changes. So I'm going to leave you with this final thought to take away. From a single smart cabin to global big data, how will you use your coding skills to shape the future? Keep learning, keep building, and I will see you in the next explainer.